A very warm good afternoon to each and everyone present here today, delegates of this 6 days International Faculty Development Program. So today we are with Dr. Parvinder Singh, who is going to deal with the ethical hacking and blockchain technology. So yes, is it not interesting? Of course it is, and it is a very vibrant topic to even listen and experience it by self. So here I take this prime opportunity to introduce today's resource person, that is Professor Dr. Parvinder Singh, sir. So who is presently a professor in Department of Computer Science and Engineering at Dinabandhu Choturam University of Science and Technology, Murthal, Haryana in India. Sir has an administrative experience as a dean faculty of IT, Information Technology and Computer Science at the DCRUST, Murthal, Chairperson, CSED, DCRUST, Murthal, Professor in charge Security, DCRUST in Murthal. So has in and out with the Deenbandhu Choturam University in Sonepat, Haryana. So, Sir has his teaching experience since October 2008 till date at the DCRUST University. Sir joined on 31st October 2008 as a chairman, Department of Computer Science and Engineering, and continued for 2 terms from November 2008, working on India Bulgaria joint project with Technical University of Sofia. Worked in collaboration with University of Deusto in Spain. Received 2 patents in the field of security and image processing. Awarded 2 grants from DST and one from UGC for major projects. Organized international and national workshops, conferences in various cities of the world. Biography published in 27th edition of Marquess, Who's is Who in World 2010 and all the subsequent editions. Inclusion in the top 100 engineers 2012 by Cambridge, England. Wow, that's really a great. We need to applaud for this. In August 2004 to October 2008, Guru Jambeshwar University of Science and Technology, Hisar, he continued to be the assistant professor in computer science and engineering. Sir has also been the president of Alumni Association of CSE department in GJU Hisar, coordinator of national level IT Fest Kshetej in 25, in charge of all the 15 computer labs of CSE department, and the list goes on and on. He has numerous publications in his name. So let's move on to his educational background, where Sir stood first class in BE Electronics from Baba Saheb Ambedkar Marathwada University, Aurangabad. First class with distinction in MTech, that is in Computer Science and Engineering, from Guru Jambeshwar University, Hisar. PhD from Maharishi Dayanand University from Rohtak. So his publications are numerous, and his really the data and the biography will be shared with you on your emails, which is really a long list, and we have to applaud for Sir for his great contribution to the nation and also his expertise. So here it's none other than Professor Dr. Parvinder Singh. I welcome you, sir, for this auspicious event. The screen is all
Thank you,
yours.
madam. Thank you, madam. Thank you for very nice introduction. So it's my good luck so that I have got chance to interact with you all people. So my topic for today talk is introduction to blockchain technology and its application. It is very near to my heart. Blockchain technologies, maybe all of you have heard about this blockchain technology. Nowadays it is very much popular in the Telangana state. So most of the work is doing by implementing blockchain technology. And recently, I have also received one paid Australian patent in the blockchain for identity management. So this topic is very near to me. So, but I will share with some starting things about the blockchain, like introduction and its application, with you all. So I think it will be okay for you. So now we'll start with introduction to blockchain technology. So madam, go to next slide, please. So as blockchain has many meaning, actually there are two terms. So maybe lot of people have heard about the bitcoins. So most of the people confuse with the blockchain and bitcoin as the same thing. But blockchain refers to a type of data structure that enables in the bitcoins. To understand the power of blockchain systems and things they can do, it is important to distinguish between the three things that are commonly muddled up, namely the bitcoin currency, the specific blockchain that underpins in it, means the blockchain make it possible. uh, it is like of data structure for the bitcoin, and the idea of blockchains in the journal. So this blockchain can be used in number of fields, not only in the bitcoins currency. So it is used in number of the fields. So we will see the lot of applications uh, in the coming slides. So madam, please go to next slide. So let us play a video about the introduction about the blockchain, which is it is explained. So please.
Blockchains are incredibly popular nowadays. But what is a blockchain? How do they work? What problems do they solve? And how can they be used? Like the name indicates, a blockchain is a chain of blocks that contains information. This technique was originally described in 1991 by a group of researchers and was originally intended to timestamp digital documents so that it's not possible to backdate them or to tamper with them, almost like a notary. However, it went by mostly unused until it was adapted by Satoshi Nakamoto in 2009 to create the digital cryptocurrency Bitcoin. Now, a blockchain is a distributed ledger that is completely open to anyone. They have an interesting property. Once some data has been recorded inside a blockchain, it becomes very difficult to change it. So how does that work? Well, let's take a closer look at a block. Each block contains some data, the hash of the block, and the hash of the previous block. The data that is stored inside a block depends on the type of blockchain. The Bitcoin blockchain, for example, stores the details about a transaction in here, such as the sender, receiver, and the amount of coins. A block also has a hash. You can compare a hash to a fingerprint. It identifies a block and all of its contents, and it's always unique, just as a fingerprint. Once a block is created, its hash is being calculated. Changing something inside the block will cause the hash to change. So in other words, hashes are very useful when you want to detect changes to blocks. If the fingerprint of a block changes, it no longer is the same block. The third element inside each block is the hash of the previous block. And this effectively creates a chain of blocks, and it's this technique that makes a blockchain so secure. Let's take an example. Here we have a chain of 3 blocks. As you can see, each block has a hash and the hash of the previous block. So block number 3 points to block number 2, and number 2 points to number 1. Now the first block is a bit special. It cannot point to previous blocks because, well, it's the first one. We call this block the Genesis block. Now let's say that you tamper with the second block. This causes the hash of the block to change as well. In turn, that will make block 3 and all following blocks invalid because they no longer store a valid hash of the previous block. So changing a single block will make all following blocks invalid. But using hashes is not enough to prevent tampering. Computers these days are very fast and can calculate hundreds of thousands of hashes per second. You could effectively tamper with a block and recalculate all the hashes of other blocks to make your blockchain valid again. So to mitigate this, Blockchains have something that is called proof of work. It's a mechanism that slows down the creation of new blocks. In Bitcoin's case, it takes about 10 minutes to calculate the required proof of work and add a new block to the chain. This mechanism makes it very hard to tamper with the blocks because if you tamper with one block, you'll need to recalculate the proof of work for all the following blocks. So the security of a blockchain comes from its creative use of hashing and the proof of work mechanism. But there is one more way that blockchains secure themselves, and that is by being distributed. Instead of using a central entity to manage the chain, blockchains use a peer-to-peer network and everyone is allowed to join. When someone joins this network, he gets a full copy of the blockchain. The node can use this to verify that everything is still in order. Now, let's see what happens when someone creates a new block. That block is sent to everyone on the network. Each node then verifies the block to make sure that it hasn't been tampered with. And if everything checks out, each node adds this block to their own blockchain. All the nodes in this network create consensus. They agree about what blocks are valid and which aren't. Blocks that are tampered with will be rejected by other nodes in the network. So to successfully tamper with a blockchain, you'll need to tamper with all the blocks on the chain, redo the proof of work for each block, and take control of more than 50% of the peer-to-peer network. Only then will your tampered block become accepted by everyone else. So this is almost impossible to do. Blockchains are also constantly evolving. One of the most recent developments is the creation of smart contracts. These contracts are simple programs that are stored on the blockchain and can be used to automatically exchange coins based on certain conditions. More on smart contracts in a later video. The creation of blockchain technology piqued a lot of people's interest. Soon others realized that this technology could be used for other things, like storing medical records, creating a digital notary, or even collecting taxes. So now you know what a blockchain is, how it works on a basic level, and what problems it solves. Want to learn how you can implement a simple blockchain in JavaScript? Then check.
Excuse me, madam. So we can go to the next slide. So this is sufficient for the introduction part. So yeah. So these are the things. So as I have explained, so blockchain is the technology which is used in the Bitcoin. Next slide, please. So then blockchain is a distributed ledger. So where means there is a no central entity. So every record is stored in all the blocks. So as it is shown in the picture. So there are 3 blocks. So same record is stored in the all the blocks. Next slide, please. So each block has, as we have seen the video, so I am again repeating it. So every block has a data. So like in the case of currency, so data is the transaction. So then there is a hash. Hash is a kind of link which is linked to the next block. So hash is calculating by the value of the data. So if even a single bit is changed in a block, the hash will change. So that's why, so all the continuous blocks, all the next blocks values will be changed. So that is for the security purpose. So we have again a third part, that is hash of the previous block. So in this, if it is first block, so it will be a genesis block. So the value will be the hash of previous block will be 000. Otherwise, so it will store the hash of the previous block. Next slide, please. So like it is shown in the case of Bitcoin example, like from to amount, the data part. So the data part contains these things. Like next slide. So like hash is a unique for every block. So you can compare it with a fingerprint. So it depends upon the content of the block. So even as I have told you, if even there is a single bit change, so the hash will change. So it is very important for the security of the blockchain. So next slide, please. So if we will change the hash of a one block, like second block in this picture, so then we have to change the link part in the third and all the other parts. So they make the work of the intruder very difficult. Next slide. So another security part is the consensus. So because it is a distributed kind of ledger, so everyone has a record. So if suppose I will change my blockchain, so it does not mean that it has changed, because most of the people, so means more than 50% have the same uh, uh, records. So then that change will be implemented. So that's why, due to the distributed ledger, so it is very difficult to make the changes in the blockchain, or next to impossible. Next slide, please. So now coming on the another thing, that is the Bitcoin. So that is the currency which is nowadays very much popular. I think everyone has know about the Bitcoin currency because of the shooting rates, but it is not valid in India. So the Bitcoin use the blockchain technology. So let us have a little bit video.
Say there's a coin that's currently worth hundreds of US dollars, but it's not made of gold or platinum or any precious metal. In fact, it's not the kind of coin you can hold in your hand or stick in a piggy bank. It's a digital currency, which means it only exists electronically. I'm talking about
Yeah,
Bitcoin.
it has. Okay,
Bitcoin doesn't
okay,
work like most.
okay. Please play. Okay,
It isn't
going to
attached
come.
to a state or government, so it doesn't have a central issuing authority or regulatory body. Basically, that means there's no organization deciding when to make more Bitcoins, figuring out how many to produce, keeping track of where they are, or investigating fraud. So how does Bitcoin work as a currency, or have any value at all? Well, Bitcoin wouldn't exist without a whole network of people and a little thing called cryptography. In fact, it's sometimes described as the world's first cryptocurrency, and here's how it works. Bitcoin is a fully digital currency, and you can exchange Bitcoins between computers in a worldwide peer-to-peer network. The whole point of most peer-to-peer networks is sharing stuff, like letting people make copies of super legal music or movies to download. If Bitcoin is a digital currency, what's stopping you from making a bunch of counterfeit copies and becoming fabulously wealthy? Well, unlike an MP3 or a video file, a Bitcoin isn't a string of data that can be duplicated. A Bitcoin is actually an entry on a huge global ledger called the blockchain, for reasons we'll get to in a minute. The blockchain records every Bitcoin transaction that has ever happened. And as of late 2016, the complete ledger is about 107 gigabytes of data. So when you send someone Bitcoins, it's not like you're sending them a bunch of files. Instead, you're basically writing the exchange down on that big ledger, something like Michael sends Hank 5 Bitcoins. Now, maybe you're thinking, but wait, you said that Bitcoin doesn't have a central authority to keep track of everything. Even though the blockchain is a central record, there's no official group of people who update the ledger and keep track of everybody's money like a bank does. It's decentralized. In fact, anybody can volunteer to keep the blockchain up to date with all the new transactions, and a ton of people do. It all works because there are lots of people keeping track of the same thing to make sure all transactions are accurate. Like, imagine you're playing a game of poker with some pals, but none of you have poker chips and you left your cash at home. There's no money on the table, so a few of you get out some notebooks and start writing down who bets how much, who wins, and who loses. You don't completely trust anyone else, so everyone keeps their ledgers separately. At the end of every hand, you all compare what you've written down. That way, if someone makes a mistake or tries to cheat and snag some extra money for themselves, that discrepancy is caught. After a couple of hands, you might fill up a page of your notebook with notes about the money movement. You can think of each page as a block of transactions. Eventually, your notebook will have pages and pages of information, a chain of those blocks. Hence, blockchain. Now, if thousands of people are separately maintaining the Bitcoin blockchain, how are all the ledgers kept in sync? To stick with our poker analogy, think of the entire Bitcoin peer-to-peer network as a really huge poker table with millions of people. Some are just exchanging money, but lots of volunteers are keeping ledgers. So when you want to send or receive money, you have to announce it to everyone at the table, so the people keeping track can update their ledgers. So for every transaction, you're announcing a couple of things to the Bitcoin network, your account number, the account number of the person you're sending Bitcoins to, and how many Bitcoins you want to send. And all of the users who are keeping copies of the blockchain will add your transaction to the current block. Having a bunch of people keep track of transactions seems like a pretty good security measure. But if all it takes to send Bitcoins is a couple of account numbers, that seems like it might be a security problem. It's a huge problem with regular money. Just think of all the ways criminals try to steal other people's credit card information. And with Bitcoin, there's no central bank to notice anything weird going on to shut down fraud, like if it looked like suddenly you spent your entire life savings on beef jerky. So what's stopping Hank from pretending he's me and just sending himself all of my Bitcoins? Bitcoins are kept pretty safe thanks to cryptography, which is why it's considered a cryptocurrency. Specifically, Bitcoin stays secure because of keys, which are basically chunks of information that can be used to make mathematical guarantees about messages, like, hey, this is really from me. When you create an account on the Bitcoin network, which you might have heard called a wallet, that account is linked to two unique keys, a private key and a public key. In this case, the private key can take some data and basically mark it, also known as signing it, so that other people can verify those signatures later if they want. So let's say I want to send a message to the network that says, Michael sends 3 Bitcoins to Olivia. I sign that message using my private key, which only I have access to and nobody else can replicate. Then I send that signed message out to the Bitcoin network, and everyone can use my public key to make sure my signature checks out. That way, everyone keeping track of all the Bitcoin trading knows to add my transaction to their copy of the blockchain. In other words, if the public key works, that's proof that the message was signed by my private key and is something I wanted to send. Unlike a handwritten signature or a credit card number, this proof of identity isn't something that can be faked by a scam artist. The who part of each transaction is obviously important to make sure the right people are swapping Bitcoins, but the when matters as well. If you had $1,000 in your bank account, for example, and tried to buy 2 things for $1,000 each, the bank would honor the first purchase and deny the second one. If the bank didn't do that, you'd be able to spend the same money multiple times, which might sound awesome, but it's also terrible. A financial system can't work like that because no one would get paid. So if I only have enough money to pay Olivia or Hank, but I try to pay them both, there's a check built into the Bitcoin system. Both the Bitcoin network and your wallet automatically check your previous transactions to make sure you have enough Bitcoins to send in the first place. But there's another problem that might happen with timing. Because lots of people are keeping copies of the blockchain all over the world, network delays means that you won't always receive the transaction requests in the same order. So now you've got a bunch of people with a bunch of slightly different blocks to pick from, but none of them are necessarily wrong. Okay, Bitcoin, how do you solve that problem? It turns out it's by actually solving problems. Math problems. To add a block of transactions to the chain, each person maintaining a ledger has to solve a special kind of math problem created by a cryptographic hash function. A hash function is an algorithm that takes an input of any size and turns it into an output with a fixed size. For example, let's say you had this string of numbers as your input, and our example hash function says to add all of the numbers together. So in this case, the output would be 10. What makes hash functions really good for cryptography is that when you're given an input, it's really easy to find the output, but it's really hard to take an output and figure out the original input. Even in this super simple example, there are lots of strings of numbers that add up to 10. The only way to figure out that the input was 1, 2, 3, 4 is to just guess until you get it right. Now, the hash function that Bitcoin uses is called SHA-256, which stands for Secure Hash Algorithm 256-bit, and it was originally developed by the United States National Security Agency. Computers that were specifically designed to solve SHA-256 hash problems take, on average, about 10 minutes to guess the solution to each one. That means they're churning through billions and billions of guesses before they get it right. Whoever solves the hash first gets to add the next block of transactions to the blockchain, which then generates a new math problem that needs to be solved. If multiple people make blocks at roughly the same time, the network picks one to keep building upon, which becomes the longest and most trusted chain. And any transactions in those alternate branches of the chain get put back into a pool to be added onto later blocks. These volunteers spend thousands of dollars on special computers built to solve SHA-256 problems and run their electricity bills up sky high to keep those machines running. But why? What do they get out of maintaining the blockchain? Is it just community service? Well, Bitcoin actually has a built-in system to reward them. Today, every time you win the race to add a block to the blockchain, 12.5 new Bitcoins are created out of thin air and awarded to your account. In fact, you might know the Bitcoin ledger keepers by another name: miners. That's because keeping the blockchain updated is like swinging a proverbial pickaxe at those hash problems, hoping to strike it rich. When Bitcoins were first created in 2009, they didn't really have any perceived value. Tens of Bitcoins would have been worth the same as a bunch of pennies. As of November 10th, 2016, though, 1 Bitcoin is worth $708 US, so 12.5 Bitcoins are worth $8,850. That's a nice chunk of change. single Bitcoin that exists was created to reward a Bitcoin miner. Besides the big payout when they add a new block of transactions, miners are also essentially tipped a very small amount for each transaction they add to the ledger. It's also worth noting that every 210,000 blocks, the number of coins generated when a new block is added goes down by half. So what started as a reward of 50 Bitcoins decreased to 25, then 12.5, and it'll only be around 6 Bitcoins in a couple more years and keep decreasing. Eventually, there will be so many transactions in a block that it'll still be worthwhile for miners to mostly be paid in tips. According to current projections, the last Bitcoin, probably around the 21 millionth coin, will be mined in the year 2140. This decreasing number of Bitcoins is actually modeled off the rate at which things like gold are dug out of the earth. And the idea is that keeping the supply of Bitcoins limited will raise their value over time. So is investing in Bitcoin a good idea? Now that's not really a SciShow kind of question. Bitcoin is still volatile and experimental. A lot of people love it and a lot of people think it's doomed to fail. We just think it's an interesting idea and it makes us wonder what cryptography might do for us next. Thanks for watching this episode of SciShow, brought to you by our patrons on Patreon. If you want to help support the show, just go to patreon.com/SciShow.
So
don't
you
forget
can go to next slide, madam.
Fine.
Yeah, stop it and go to the next slide. Next slide. So as we have seen in this previous video, so it is about the Bitcoin. So it has shown how the blockchain has implemented the Bitcoin. So all the necessary questions will be have answered in this. So go to the next slide, madam. So I will already covered this, what is blockchain. So we can go to the next slide. So what is distributed ledger? So central ledger is like about the bank, where is all the record will take place in one kind of server. But in the case of blockchain, it is a distributed ledger, as we have seen that. So there are all the nodes take the all the transaction copy of the transaction. So that is a distributed kind of ledger. So go to next slide, madam. So and then what might blockchain use? Cryptography. So yeah, it use digital signatures and private and public key for the broadcasting of the transactions, and validation of transaction. It use the proof of work and other certain alternatives. And about of chaining blocks, so it use the hash functions. So hash function, proof of works, that the hard problems, and the digital signature and private and public keys are the cryptographic technologies which are used in the blockchain, so to make it more secure and hard to break. So next slide, please. So a blockchain is a historical record of transaction, much like a database. Block in a chain is the, you can compare it with the pages in the book. Each page in a book contains like the text, the story. Each page has the information about itself, like the title of the book, chapter title, page number. So that may be a like metadata about that particular page. Similarly, in the blockchain has a header which contains the data about the block, like the technical information, a reference to the previous block, and a digital fingerprints of the data contained in the block. Among the other thing, the hash is important for our ordering and block validation. The contents of the block, for example, information about the transactions, like what is stored in the, what is all about it. So that is stored in the blockchain. So next slide. Yes, next slide, please. So you can go to the presentation. Okay. So blockchain, how do they work? So a blockchain is a sequence of a hash chain records. So once you have seen the record n, you can change. You can't change anything in the past because the hash is stored. So that hash is stored in the next slide. So next slide. So it means there is no possibility at all that you can change any record in the past. So that make it the most secure thing, blockchain data, because you can't change anything in the past. Some procedure for text to add block, how it is done. So that is for validation conditions for the new block. So actually the number of so there are number of how the transactions are valid. So are digital signature correct, it is there number of enforcement by the consensus. Chains with the invalid blocks would not be accepted. Some procedure for deciding between the alternate candidates of blockchains are there. So when Alice and Bob have different pictures of history, there is some way for them to eventually come to the agreement about who is the right. So how we will decide it? So that is a consensus. Like if more than 50% people in the chains are saying something, so that is the acceptable thing, that is the right thing. Others are false things. So we can go to the next slide, please. So what about hash functions? So as we have seen in the case of Bitcoin, we use the SHA-256 principle or the protocol. So takes any bit string as a input like 10 MB file. It produces a fixed length output like typically 256 or 512 bytes. So nobody can find the collision in it. So that is the for the block. So it means it will act like as a fingerprint. Sometimes that is a really huge maximum input length, but the output will be like if we are using SHA-256, so it will be 256 bits only. So if we are using SHA-512, so the output will be 512 unique bits. So that is all about the hash things. So now coming on the next slide, please. So it has already covered, like, so it is an index previous. So go to the next slide, please. So go to the next slide. Next, 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 next. So now, yeah, please play this demo. So it is show it. This demo will show how it works. So, but it is a little bit technical thing. So I think we can leave it blockchain demo. So we can come to the next slide and go to the application parts. So we have covered most of the parts of the blockchain demo. Madam, go to the next slide, please. Next slide. So adding new blocks to the chain, any block system has to determine who can add new blocks to the chain and how it is done. So there are two main ideas like proof of work and permission blockchain. So like proof of work is used in the Bitcoin. So other may be a permission blockchain, like in your company you can make your own blockchain. So then you can fix the right who can add the block. So that will be called the permission blockchain. It depends upon the applications, so where you are using the blockchain, because it is actually a data structure. So depend upon the use, so whether you can make it is a proof of work type blockchain or permission blockchain. But if you will use the proof of works, so it means, so first one, anyone who want to add a block has to solve some mathematical problem or some kind of quiz, so that it will take at least 10 minutes to add the new blocks. So it means, so we are delaying the process. We are delaying the process so that no intruder can make the all the block changes. However, there are a lot of other things like consensus is there, then hash is there, and we can't change in the previous record. So, but proof of work is next slide. Next slide. Yeah. So I want to do a big computation. So like in proof of work, so we do a big computation, as I have told you, then it may be a quiz or maybe a mathematical problem. So once you did it, I don't want to do much work checking the proof. So why is this useful? It limits the rates of new block because we are slowing it for the security purpose, so that if there is any intruder, so he can't change all the blocks in the by using some computing technologies. So it makes attempt to add invalid blocks to the chain expensive. It provides a clear way to decide between the competing chains when there is a disagreement. The one with the most work wins. So not all blockchain use proof of work. Like as I have told you, so there may be some kind of permissioned blockchain also. So in which blocks can be added by some kind of limited number of users. So next slide, please. So next slide, please. We can leave these technical problems. So next slide. Next. So yeah, this is a, yes, previous slide, please. So permission blockchain is an alternative to a proof of work. We have set of somewhat trusted entries who can work together to add records to the blockchain. For example, we could have 5 trustees, and if any three of the 5 votes in the favor of accepting a block on the chain, then the block is added. So like you can compare it with like a UN type of thing. So where there are 5 major countries are deciding who are in the security. So if there are in consensus between all the 5, so then it is okay. So if there is some kind of disagreement, then there who have majority will win. So validation condition for adding a block is like if there are 5 things, 5 trustees, then so it may be a 3 out of 5 because more than 50%. So resolution for conflicting chain, look for the longest chain, means most votes. With 3 into 5 there should not be any forked chain. Someone would have to vote for the 2 competing blocks. Yes, next slide. So this is again a wrap up. Blockchain let us agree on the history. We do not have to trust each other. We don't have a trusted third party like in the bank case. So there is a third party kind of thing. Like in all the transactions, most of the times you have the government who is the you have to trust. Or like if you are taking from some company, you have to trust that company. So that is the management of the company you have to trust. But in the case of blockchain, it is a peer-to-peer network. So if most of the people or like 50% of the people agree on one thing, so then it is a the kind of distributed kind of thing. So system is distributed, agreeing on the history, agreeing on the state of the system. Yeah, next slide. And the another thing is blockchain and hash chains. So the nth record in the hash chain commits to the all previous records, because if hash in any of the previous block is changed, it effect will be reflected on the all the next blocks. So that's why hash make it strong to change the history. So we can't make change in the history of the transactions in the block because of the hash functions. So we can't change any previous record without making hash chain invalid. Next slide. So most blockchain in use now use proof of work. So many new proposal use permission blockchain, where instead of all the have the same rights, so some kind of people or trustees maybe have more rights than the other. Yes, next slide. Now coming on blockchain adoptions and applications. So blockchain has not only one applications, like we have seen the cryptocurrency. So it is now used in lot of fields. People are coming with many innovative ideas of the blockchain technologies, because what the blockchain has features. So as we have seen that first of thing is there is a no centralized agency in it. So means it is a peer to peer confidence. So means you have to trust it. If you want to make a trusted chain, or you want to make a decision according to the where you want a strong kind of mechanism where no one can change the record in the previous history, so then you can go for the blockchain. So that is another feature of the blockchain. So due to these features like decentralized trust, so where you want trust between the peers, and where you can't want to make the change in the history of the transactions. So in all those kind of applications, blockchain can be adopted. Like some examples are consumer products, manufacturing, technology, media, telecommunication, healthcare, life science. So but the problem is that there is a less awareness about the blockchain adoptions. So like it is given like written here, like 39% of the senior executives at the large US companies initially surveyed indicate that they have little or no knowledge about the blockchain technology. If you will don't have any knowledge about the blockchain, then how you can go for the adoption purpose? So that's why the awareness of the blockchain technologies is important. So many deem it to be crucial for their companies and industry. 42% believe it will disrupt their industries. So let us see how it will disrupt their industries, or how they can take the advantage of these using blockchain technology in the next slides. Yes, next slide, please. Like one of the example is the financial service industry. As noted by Michael Smith, in creating assurance in the blockchain, trust and efficiency are the main value drivers for any use case. The finance world is driven by this technology, because in the blockchain we have the assurance, we have the trust, we have the efficiencies. So due to that, tracking risk and monitoring compliance with the laws and regulations within an interesting complex cybersecurity environment requires considerable time and resources. The financial service industry immediately saw opportunities in the blockchain and has been investing heavily in the usage, primarily as a part of private implementation. Yes, next slide. Another is the identity management. Identity management means you have to identify a person, like your Aadhaar card, your passport, these kind of things. So the blockchain can be used. So identity management is the has lot of applications, because due to blockchain has the centralized not centralized facility and the distributed kind of ledger things. So everyone will have the access of the identity of anything by using, as we have seen that, by using private and public key combinations. So one can store his identity by using private key, and anyone using the public key can see the identity or can verify his identity by, if like if I will share my public key with everyone, so anyone can uh, it uh, it can check or verify that this identity is given by me, because otherwise it will not be possible to know the details if you don't have my public key, and that public key will be shared by me itself, like if I want to share my information about my identity. Next slide. Another is the distributed access management. Creating an identity on the blockchain can give individual greater control over who have their personal information and how they access it. Like areas impacted include passports, e-residency, birth certificate, wedding certificates, ID, online accounts, login, etc. So everything can be put on the distributed kind of this ledger, or that can blockchain technology. So it means, so most of the peoples will have the same details, so nobody can change it in the past. So one can verify and one have the assurance that this data is correct. So digital IDs can provide digital watermarks, so that can be assigned to every online transactions of any assets. So that is the distributed access management. Next slide, please. A part of it, protecting private keys. Within the blockchain, trust relies on the safe keeping of the private keys in the spot of truly distributing identity management. Ultimately, the safekeeping resides with the action taken by individual to secure their private key. Like if I want to secure my data, so then I have to encrypt it with my private key. Then I can share my public key. So for by public key, anyone can view, who have the public access to my public key can view my data only, but can't change it. For cryptocurrency traders, so one frequently sees the recommendation to write one's private key down on the piece of paper and put it up in the safekeeping in, for example, a safe deposit box. So so that no one can change it. So only the private key holder can change it. So then it is my responsibility to maintain my private key. Yes, next slide, please. So now we will see some 4 applications. Yes, please play. It is a video file.
We're living in a period of extraordinary change. There's nobody you've ever met, or I've ever met, who's lived in normal times. 200 years ago, the overwhelming majority of people on the planet lived the same way they always had. Whether it was in Europe or in China or in Africa or Latin America, they were farmers. They were at the mercy of the weather. They had moved more than 10 miles from wherever they had been born. That was their natural world. We're in a period now since the beginning of the internet revolution where this technology has collapsed space globally. It's remarkable, and it's introduced yet new avenues for communication, for human interaction, for building wealth. We're also seeing political change as well. While we can't assume the internet is sort of a magic wand that democratizes the world and opens it up, the tendency has been for it to do that. With blockchain now, we're seeing the next step forward.
So what we're seeing actually is a positive shift in the dynamics of the capital markets. When we think about capitalism as a system, it's still the best system the world has ever known for creating value. But systems generally are reluctant to change. To optimize a system, you want to maximize the communication and the conversation among each of the pieces. Every time we move a dollar or a euro or a Bitcoin, every time we move a piece of value, we need to understand where it's going. And because the trust in the systems has been damaged, we all have the right to know. What we are moving towards is a place where there's more accountability, more incentivization, more reality, more honesty in what we can and cannot do.
One of the reasons that the blockchain has such resiliency compared to a centralized system is the centralized system, it can work, but it's also a single point of failure. The blockchain, because it's a distributed ledger where the recording of all those transactions isn't just happening in one place, it's written in thousands and thousands and thousands of places, it can't go down. And it's always transparent, you can always look it up. So it's hard to hack, because to try to replace or erase and change the information, you'd essentially either have to take over every single one of those computers around the world, writing it down at the same time, or you'd have to double the whole network all at once, which it's really kind of impossible at the scale it is today.
We need the people to trust the blockchain because it's really the future. It's the future of everything that we are doing. It will change commerce, it will change industry, it will change healthcare, it will change everything. Nowadays, there are so many evil bodies and so many entities that are trying to harm and attack. So it's understood why people are worried. But when everybody is voluntary into it, and you understand that the duplicate of information, the same information all over the world, is the best security system for you, and you understand how robust it is, how difficult it is to change it and to take it, you'll feel much more comfortable. And I know that the people that will be here in 10 years and 50 years will not even understand our worries and our concerns. It will be so obvious that this is the way we live.
These systems are very young. There's a lot of building that we need to do, both at the protocol layer and at the application layer. We still need to build more scalable systems. We need to build systems that better handle privacy and confidentiality. At the application layer, we need to build layers and layers of functionality. but also make it easier for the general population to operate this thing. That's going to grow participation and enfranchisement. In terms of just number of transactions per second throughput, we have a lot of ground to go and an excellent roadmap, really. I do believe that we're going to get to very significant throughput, many thousands of transactions per second, eventually millions, and eventually infinite transactions per second. And then we add the machines, then we add the sensors and have essentially a machine-to-machine economy. So that's going to be big.
Yes. So we have seen that most of the industry leaders are saying very good words about the blockchain technologies or blockchain adoptions. So we have seen that their future is very much bright in the blockchain. So that's why most of the countries are expanding or doing a lot of investment in the blockchain technology because of the because it is considered as a most of the most promising technologies in the near future. So next slide, please. Yeah, slide, please. So we have already covered this. Next slide. Next. Okay. So we come on the private securities. Previous slide, please. Previous slide. Yeah, like private securities nowadays. Everyone know that in our country, so we have some kind of sensex system or but in the case of private securities, so that can be again implemented by using blockchain, because the application of blockchain is number one, nobody can change the transactions in the history. So that is the requirement in the case of stock exchange. A part of it, you want securities in there in blockchain because of the usage of number of things. A part of it is a distributed kind of thing, so everyone has the ledger, so everyone can see it. So means another kind of security or the trust is there. So that's why Nasdaq Private Equity has joined hands with a San Francisco based startup called blockchain chain.com to implement private equity exchange on the top of chain.com. Is implementing blockchain based smart contracts to implement exchange functionality. The product is expected to be fast, traceable, and efficient. A part of another application is Medikey is being developed as a security exchange that uses the counterparty implementation of Bitcoin 2.0. Another is a Coinsetter, is a New York based Bitcoin exchange. It is working on a project Highline, a method of using the blockchain to settle and clear the financial transaction in T plus 10 minutes rather than customary T plus 3 or T plus 2 days. Like if you have someone has used the exchange, so then if you have made some transactions, so it will be reflected in 2 days or 3 days in generally stock exchange. But by using this blockchain technology, if we will implement a stock exchange by using blockchain technology, so then that can be implemented in 10 minutes. So that is the time of work of proof of work. So after that, that block can be added. So that means, so it will take very fast. Next slide, please. Next slide. So another is insurance. So Everg Ledger is a company which create permanent ledger of diamond certification and transaction history of the diamond using blockchain. So you have listened lot of stories about the means the purity of the diamond. So last time there is a, like in India there was a case of Gitanjali diamonds, so where he has gifted lot of duplicate diamonds to his guest or his nons, so but their value was zero. So you can't track the record, you can't track the trust of the diamond. So that's why Everledger has company has created a permanent ledger of the diamond certification. So means, so it is a distributed kind of thing. So where the history of the diamond when it was uh, from the mind, so then what has and how it has passed from the different hands, so everything will be recorded in that transactions, so that you will be sure that it is a genuine diamond. So the characteristics which uniquely identify the diamond, such as height, width, weight, depth, color, are hashed and registered in this kind of ledger. Again, so it will store the complete history. So how this diamond has traveled from one hand to another hand, so that you are sure that it is a genuine diamond. So it has genuine value. So that is a one of the promising application in the case of insurance of the diamond. So that is coming with Everledger companies coming with by using blockchain. Next slide, please. Another is the Nordic Republic. So like in your, you take example of the our country, so there are lot of properties are there where we can't track the history of that property, who is the genuine owner of that property. Nowadays we have used in the kind of registry where the photograph is taken, but if you take the old type of uh, history of any property, so then it is very difficult to track who is the actual owner. So but by using blockchain, if we will implement all these records by using blockchain technology, then nobody will able to change the record in the past. So that is the feature of the blockchain technology. So means blockchain can be used for this kind of storage of records. So considering that a company named Stampry is a company which can stamp email or any file using blockchain technology. So it is Stampry is only for the files or the emails, for the to check the genuinity. A part of it, another application is Viacom, which is one of the companies which uses clearing house protocol for notary services. Another is a block notary. It is an iOS app which helps you to create proof of existence of any content like photo, files, or any media using testnet 3 at or a Bitcoin network, so that who is created this photo and all the files history will be stored in this block notary. A part of it, there is a crypto public notary uses blockchain of Bitcoin to notarize the documents by using tribal amount of Bitcoins to record the files checksum in public blockchain. A part of it, another application which is there in market, that is proof of existence, is another service which uses blockchain to SHA 256 digest of the document in the Bitcoin blockchain. So these are the some of the applications which are available in the market for the files, digital files or emails or the documents of the yes, next slide please. Another is the application of blockchain in the music industry. Like in music industry, if one company has created an album, so then how the revenue will be shared. So if we can track how many copies are sold, anyone can see it. So if we'll implement using blockchain technology, then it is very easy to track the total exact number of copies of sales of the that particular cassettes or the music file. So accordingly the revenue can be shared. So that is the another application. The technology can help to maintain a comprehensive and accurate distributed database of music rights ownership information in a public ledger. In adoption to right ownership information, the royalties split for each work as determined by smart contract could be added to the database. The smart contract would in turn define the relationship between the different stakeholders and automate their interactions. So every like if one copy will sell, so the revenue will be shared between all the stakeholder. It will come automatically to their bank account, so it can be automated. So it is a very transparent kind of systems to distribute the revenue or share the revenue of the actual sales of the music files. Yes, next slide, please. Another is the decentralized storage, like cloud file storage solutions such as Dropbox, Google Drive, or OneDrive are growing in popularity nowadays for store the documents like photos, videos, and music files. Despite their popularity, cloud file storage solution typically face challenges in areas such as security, privacy, and data control. Like in presently, a lot of people fear that their files can be misused by the third party who has complete control. So the major issue is one has to trust a third party with one's confidential files. So the solution is by using blockchain technology. The storage, which is a system by using blockchain technology, it provides a blockchain based peer-to-peer distributed cloud storage platform that allow user to transfer and share data without relying on a third party data provider. So here the storage is shared between the peer-to-peer, and the files are stored in a is in cryptographic manner, so that it is shared but one cannot view. So again, you don't have to depend on a one single party, so it is shared between peer-to-peer storage. So that is another kind of application where blockchain can help. Yes, next slide. Another is decentralized IoT. So IoT is Internet of Things is a nowadays very much popular. The blockchain technology facilitates the implementation of decentralized IoT platforms such as secure and trusted data exchange as well as record keeping. So IBM in partnership with Samsung has developed a platform Adapt, that is autonomous decentralized peer-to-peer telemetry that use elements of the Bitcoin's underlying design to build a distributed network of devices or decentralized Internet of Things. And Filament is a startup that provides a decentralized IoT software stack that use the Bitcoin blockchain to enable devices to hold unique identities on a public ledger. So means blockchain is also taking part in the Internet of Things for decentralized purpose. Yes, next slide. So next slide. So there are a lot of applications. So there are some given real world uses case. Like most of we have covered. So we can go to next slide. So we will come to next slide, please. So if you will type blockchain uses on your Google World, so you will see lot of new applications. So every day new app usage or new application is coming. So only you have to type blockchain uses or blockchain news, you will see that lot of countries or lot of peoples are doing, or lot of days new news is coming that that country or that company is using blockchain technology or going to the blockchain technology. So blockchain is a very happening thing nowadays. Yes, next slide. So now we'll see blockchain as a surprise. So 4 surprising uses of the blockchain. Let us see. So what are the surprising uses of blockchain? So they are very interesting. Yes, previous slide, please. Previous. For no. Previous. So previous. Yeah, this one. like preventing human trafficking. So Microsoft is working on using blockchain. And there is tracking blood diamonds. And there is like as shaking up the music industry, release our song. So many artists are selling direct to the, and there is registering land. Sweden is experimenting with putting its land registry system on blockchain. Even in India, in Telangana, so blockchain has used. Yeah. So next slide, please. So now we will see 90 industries where the blockchain will disrupt. So means that will actually change the face of these industries by using blockchain. So let us see which industries are going to be disturbed by the blockchain. Yes. No, previous. No, this slide.
It's one of the most
Yes, please. Okay.
The blockchain is one of the most promising new technologies for the future. So what is it? It's a distributed ledger technology that underlies cryptocurrencies like Bitcoin and provides a way to record and transfer data that is transparent, safe, auditable, and resistant to outages. The blockchain has the ability to make the organizations that use it transparent, democratic, decentralized, efficient, and secure. The blockchain is likely to disrupt many industries in the coming 5 to 10 years. These are some of the industries it's already disrupting.
Number 1, banking and payments. Some people say that the blockchain will do to banking what the internet did to media. Blockchain technology can be used to give access to finance.
Hello. 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 Ah, yeah, so it has shown that only M is there in the show.
verify the authenticity or fair trade status of products by tracking them from their origin. Some blockchain startups working in this sector are Providence, Fluent, SkuChain, and BlockVerify.
Number 4, forecasting. Blockchain is set to change the entire approach to research, consulting, analysis, and forecasting. Online platforms like Augur are looking to create global decentralized prediction markets. These technologies can be used to place and monitor bets on anything from sports to stocks to elections in a decentralized way.
Number 5, networking and Internet of Things. Samsung and IBM are using blockchain technology for a new concept called Dept, which will create a decentralized network of IoT devices. Operating like a public ledger for a large number of devices, it would eliminate the need for a central location to handle communications between them. The devices would be able to communicate to each other directly to update software, manage bugs, and monitor energy usage.
Number 6, insurance. The global insurance market is based on trust management. Blockchain is a new way of managing trust and can be used to verify many types of data in insurance contracts, like the insured person's identity. So-called oracles can be used to integrate real-world data with blockchain smart contracts. This technology is very useful for any types of insurance that relies on real-world data, for example, crop insurance. Eternity is one blockchain project that is building tools that are useful in the insurance industry.
Number 7, private transport and ride sharing. The blockchain can be used to create decentralized versions of peer-to-peer ride-sharing apps, allowing both car owners and users to arrange terms and conditions in a secure way without third-party providers. Startups working in this area include Arcade City and Lazuz. The use of built-in e-wallets can allow for car owners to automatically pay for parking, highway tolls, and electricity top-ups to the vehicle. UBS, ZF, and Innogy are some of the startups developing blockchain-based e-wallets.
Number 8, cloud storage. Data on a centralized server is inherently vulnerable to hacking, data loss, or human error. Using blockchain technology allows cloud storage to be more secure and robust against attacks. Storage is one example of a cloud storage network using blockchain technology.
Number 9, charity. Common complaints in the charity space include inefficiency and corruption, which prevent money from reaching those who are meant to have it. Using blockchain technology to track donations can let you be sure that your money is going to end up in the right hands. Bitcoin-based charities like BitGive Foundation use blockchain's secure and transparent distributed ledger to let donors see that the intended party has received the funds.
Number 10, voting. Probably one of the most important areas of society that blockchain will disrupt is voting. The 2016 US election is not the first time certain parties were accused of rigging election results. Blockchain technology can be used for voter registration and identity verification, and electronic vote counting to ensure that only legitimate votes are counted and no votes are changed or removed. Creating an immutable, publicly viewable ledger of recorded votes would be a massive step forward in making elections more fair and democratic. Democracy Earth and Follow My Vote are two startups aiming to disrupt democracy itself through creating blockchain-based online voting systems for governments.
Number 11, government. Government systems are often slow and opaque and prone to corruption. Implementing blockchain-based systems can significantly reduce bureaucracy and increase security, efficiency, and transparency of government operations. Dubai, for example, is aiming to put its government documents on the blockchain by 2020.
Number 12, public benefits. The public benefits system is another sector that suffers from slowness and bureaucracy. Blockchain technology can help assess, verify, and distribute welfare or unemployment benefits in a much more streamlined and secure way. GovCoin is a UK-based company that is helping the government to distribute public benefits using blockchain technology. The blockchain is also a good contender for implementing a basic income. Circles is a project working on developing a blockchain-based technology for implementing a universal basic income.
Number 13, healthcare. Another industry that relies on so many legacy systems and is ripe for disruption is healthcare. One of the challenges hospitals face is the lack of a secure platform to store and share data. They're also often victims of hacking because of outdated infrastructure. Blockchain technology can allow hospitals to safely store data like medical records and share it with the authorized professionals or patients. This will improve data security and can even help improve accuracy and speed of diagnosis. Gem and Tyrion are two startups that are working on disrupting the current healthcare data space.
Number 14, energy management. Energy management has been a highly centralized industry.
Number 15, online music. Several blockchain startups are coming up with ways for musicians to get paid directly from their fans without giving up large percentages of sales to platforms or record companies. Smart contracts can also be used to automatically solve licensing issues and better catalog songs with their respective creators. Mycelia and Ujo Music are two startups creating blockchain-based solutions in the music industry.
Number 16, retail. When you shop, you trust the retail system of the store or the marketplace. Decentralized blockchain-based retail utilities work differently. They connect buyers and sellers without a middleman and associated fees. Sorry, Amazon. In these cases, trust comes from smart contract systems, the security of exchanges, and built-in reputation management systems. Two startups disrupting the retail space are OpenBazaar and OB1.
Number 17, real estate. Some of the issues in buying and selling real estate are bureaucracy, lack of transparency, fraud, and mistakes in public records. Using blockchain technology can speed up transactions by reducing the need for paper-based record keeping. It can also help with tracking, verifying ownership, ensuring accuracy documents, and transferring property deeds. Ubig is a blockchain-secured platform for real estate keeping, an alternative for legacy paper-based systems.
Number 18, crowdfunding. Crowdfunding has become a popular method of fundraising for news to create trust between project creators and supporters, but they also charge high fees. In blockchain-based crowdfunding, trust can raise funds by blockchain-based crowdfunding is uncertain. It's an area that holds a lot of promise.
Number 19, your industry. If your industry deals with data or transactions of any kind, it's likely a field that can be disrupted by blockchain technology. The space is wide open and the opportunities are many.
Did we miss anything? What are some other industries the blockchain is disrupting? Leave your comments below.
Yeah, next slide, please. So the world's first blockchain smartphone is in the Indian defense market. So there is a one smartphone which can be useful for the defense market. So that use the blockchain. The talk is going on between the that company and the defense market. So next slide, please. Yes, next slide. Yes, next slide. Is it working? Yeah, military plans to deploy blockchain. So that is the US is also going for the blockchain implementation. Next slide, please. Yes. So next slide. So as we have seen that there is a lot of future in the blockchain technologies, like from the military application to the market, to the stock exchange, to the music industry, for the land record, to stock exchange. So there are a lot of application in blockchain. So that is all from my side. The future of blockchain is very promising. So I request all of you to see the latest news or latest development in the blockchain and keep an eye on this blockchain technology, because it is going to change the future in your market. Thank you.
The blockchain is a shared database technology that underlies Bitcoin and Ethereum. It's set to disrupt many industries in the coming decade, but few people know the positive impact that it could have on the environment. Blockchains can help reduce bureaucracy and fraud, make organizations more transparent and democratic, help track the origins and movements of products, and encourage people and institutions to adopt environmental practices. Here are 7 ways the blockchain can help protect the environment and reverse climate change.
Number 1, supply chain management. Most people prefer to buy products that are ethically produced, but it's not always easy to find that information. Products go through many hands before they reach the store shelves, and it's very easy for companies to lie about how their products were made, what materials and chemicals they use, where they dump their garbage, or how fairly they treat their employees. Blockchains can be used to track products from the producer to the store shelf and help prevent waste, inefficiency, fraud, and unethical practices by making supply chains more transparent. They can also help consumers to be better informed about how each product was made and shipped, so that they can make more environmentally friendly choices. If we tracked food, for example, this could enable buyers to purchase local produce knowing that it was grown locally. It would also help cut down on carbon emissions due to food not having to travel long distances. Blockchains could ensure that a fish being sold at a fish market actually came from a sustainable fisherman, or verify that a bag of coffee actually came from a fair trade producer. FoodTrax is a blockchain-powered app in development that aims to do just that: track food from the source to the store shelf. Provenance is a startup using blockchain technology to make supply chains more transparent.
Number 2, recycling. Current recycling programs often give little or no incentive for people to participate. The responsibility for running these recycling programs often falls on individual cities, and it can be difficult to track their impact. A recycling program on the blockchain would encourage participation by giving a financial reward in the form of a cryptographic token in exchange for depositing recyclables like plastic containers, cans, or bottles. It would also make it easy to transparently track the amounts of materials recycled, costs, and profits, and evaluate the impact of each participant in the program. Recycle the Coin is an app that provides a token reward for returning plastic containers using automated machines. Plastic Bank is another blockchain-powered project that enables the exchange of old plastic for money, items, or services in third world countries.
Number 3, energy. Traditional power grids are centralized, which can create inefficiencies in energy distribution, like having unused surplus. In parts of the world affected by natural disasters or poverty, power outages can leave people without access to electricity for long periods of time. A peer-to-peer blockchain-based energy system would reduce the need to transmit energy over long distances and save the energy that could get lost along the way. By locally directing energy from where it's produced to where it's needed, it would help reduce the need for energy storage. Transactive Grid is a joint venture between Consensus and LO3 that is working on a blockchain platform that solves this problem. Sun Contract is a blockchain-based peer-to-peer energy trading platform for solar and other renewables. Power plant installations are expensive and are often financed by governments or large private companies. A blockchain-based platform would allow people to directly invest in renewable energy installations in their area and around the world. EcoChain is a blockchain app in development which aims to do exactly that. Electric Chain is another blockchain platform with several apps like SolarCoin, which aims to incentivize solar installations around the world.
Number 4, environmental treaties. It can be difficult to track the real impact or compliance of environmental treaties, and sometimes there isn't an incentive for governments or corporations to keep their promises. Fraud and manipulation of data are also problems in this area. Around $979 million is spent annually on administering the global carbon credits system alone. The blockchain can be used to transparently track environmental data and show whether commitments were met. Once the data is entered into the public blockchain, it stays there forever. Using the blockchain to track carbon credits and legal documents would cut down on administration costs and discourage corporations and governments from backpedaling on their environmental promises or misreporting their progress.
Number 5. Nonprofits. When you donate to an environmental charity, it can be difficult to track where the money goes or how it is spent. Bureaucracy, corruption, and inefficiency are still common in the charity space. Blockchain technology can ensure that money intended to be a reward for conservation or a payment to a specific cause does not disappear into unintended pockets through bureaucratic labyrinths. Blockchain money could even be released automatically to the right parties for meeting specific environmental targets. Blockchains enable funds to be transferred without bank accounts. This is beneficial to people in countries without good banking infrastructure. This means that it's possible to send money directly to people who need it without going through a complex web of middlemen or centralized authorities. BitGive Foundation and BitHope are two blockchain projects focused on ensuring that donations go where they're intended.
Number 6, carbon tax. In the current system, it's hard to see the environmental impact of each product, and its carbon footprint is not factored into the price. This means that there is little incentive for consumers to buy products with a low carbon footprint or for companies to sell such products. Tracking the carbon footprint of each product using the blockchain would protect this data from tampering, and it can be used to figure out the amount of carbon tax to be charged at the point of sale. If a product with a large carbon footprint is more expensive to buy, this would encourage buyers to buy products that are more environmentally friendly, and would encourage companies to restructure their supply chains to meet the demand. A blockchain-based reputation system could also give each company and product a score based on the carbon footprint of the products they sell. This would make manufacturing more transparent and discourage wasteful and environmentally unfriendly practices.
Number 7. Changing incentives. In a world of complexity, it can be difficult for individuals or companies to see the direct effect of their actions. The incentives for acting in an environmentally sustainable way aren't always clear, especially in the short term. Blockchain technology can help both individuals and companies to see the real impact of their actions and encourage them to take the actions that benefit the environment. The blockchain can be used to transparently track the carbon footprints of products, greenhouse gases or waste emissions from factories, or a company's overall history of compliance to environmental standards. Companies and individuals can be encouraged to act in environmentally sustainable ways through transparency of information, credits being issued for taking certain actions, or blockchain-based reputation systems. Using blockchain technology, these new incentives could completely change what drives our economy and benefit not only us, but the future generations living on our planet.
How can you become part of the solution? Research blockchain projects who are working on solving these problems and support them by sharing their projects on social media, donating, or investing. For links to any of the projects we mentioned, check the description of this video. You can also find out more about impactful blockchain projects by going to giantsupernova.com. Know another blockchain project working on solving environmental problems? Leave a comment below.
So thank you very much. That's all from my side today. So I thank everyone who has attended this presentation. So that's all from my side.
Thanks a lot, sir. Thank you. It was really a very great delivery, and also the information what you put across to the users was very vast, and it actually covered in a nutshell. And yes, that served the purpose of getting to know what all about the blockchain and how the technology is building or is breaking the things all over, and how we have the role to play here to make it one ethical thing. So thanks a lot, sir, on behalf of the institution KLE Society's JG College of Commerce. I extend my gratitude for your valuable time sharing the knowledge with us, and also sincere apologies to all the delegates due to some technical issues. We are being facing some hindrances in the streaming. So as of now, so all the other materials will be shared in the group as well as your emails. So kindly be on it and get ready for the next session tomorrow. And thank you once again. Thank you, everyone.
So now can I leave?
Yes, sir. Sure. Yeah.
Okay, thank you.